Richard Sever is assistant director at the Cold Spring Harbor Laboratory and co-founder of medRxiv and bioRxiv. Richard has a background in biochemistry from Oxford and a PhD from Cambridge in the UK, or sorry, the MRC Laboratory of Molecular Biology in Cambridge. He moved into editorial work, working at Current Opinion in Cell Biology and later Trends in Biochemical Sciences before moving to Cold Spring. So Richard, first of all, thank you for joining us. Appreciate it.
You're welcome.
Why don't you just give us a little bit of background in terms of the inception and growth of medRxiv and bioRxiv for those who might not be familiar.
Yeah, well, I mean, I guess the first thing says it's not an original idea. I mean, the inspiration, of course, was Archive, which had been going for quite a long time before we launched bioRxiv. And I guess that one of the questions was always, could this work in biology? There'd been various proposals for this to happen and various attempts to do it, which hadn't really worked, many never even got started, hadn't really got traction. But I think, I began to kind of like look at what was happening in genomics in particular. There was a lot of physicists and mathematicians moving into genomics. So I think there was a bit of its kind of change in the population of scientists, and it really looked like people were ready for this. And so we decided that we would go ahead and do this at Cold Spring Harbor Lab. And I think the important thing for us there was that Cold Spring Harbor is, I mean, for those people who don't know, it's a very well respected molecular biology and genetics lab, and is frequently ranked #1 in the world in those fields. So it has a big kind of like footprint as an academic institute, which I think imbues it with a lot of trust from scientists in that respect. But it's kind of almost better known as a communication hub where scientists have been coming for decades to learn about research. And we have these meetings that the amazing findings about DNA were presented kind of decades ago. So it had this kind of unique combination of being a research institute that would have trust among the scientific community and some kind of like know-how on the SciComm front. So we really thought that, I mean, I certainly thought that it was inevitable that something was going to happen like this, and it made sense for it to be us. And, we spoke to kind of a lot of academics, launched bioRxiv in 2013. And, 8 years on, we now have, sort of 3,500 papers submitted every month. It's been a wonderful success story in which the biomedical scientists have really voted with their feet. What was interesting was that pretty early, we were very careful early on not to have clinical research. We said, we felt that there were different things about clinical research, the risks and the dangers of, the kind of misinformation we talked about earlier were significant. So bioRxiv was explicitly non-clinical. But then I had a phone call with Eric Topol from Scripps and Harlan Krumholtz from Yale a few years later, and they said, look, what you guys are doing for basic biology should be done for clinical research as well. So we dipped our toe in the water at bioRxiv with a sort of section on clinical trials for a while, and some epidemiology, and that kind of went okay. And then it became clear that there were people in the medical community who wanted this to happen en masse. And actually Harlan Krumholtz from Yale and his colleague Joe Ross joined with us, and other colleagues from BMJ to create medRxiv as a separate server in 2019. And the idea behind that was that, for clinical information, we would have a much more kind of thorough screening procedure. We would worry about ethics, and there would be all these kinds of things that meant you would take more care with clinical research papers. You would turn away a lot more when we screen things. And so that was 2019, and I guess boy was it lucky timing, because that we launched midway through 2019, and in 2020 I think it was the 18th of January, we got the first COVID preprint, and then I think we've had like 15,000 since then, and it's been really pretty amazing. It was very fortunate, and there's lots of clinicians that contacted us to say, you know, to say exactly that. That was really good timing. So we're lucky it happened, because it has provided a very valuable service to that community.
Mm-hmm. Yeah, certainly. Certainly a very interesting time. Um, so from your perspective, what's the primary driver of why a researcher would submit to one of these preprint services? Is it
I think it's a combination.
attention?
I think it's a
Yeah.
combination of things. I mean, I think primarily it's, the big difference with the preprint server compared with the journal is it puts the author in total control of the dissemination timing. So, whereas the problem you submit to a journal, and then there's the sort of stochastic nature of peer review, you don't know. But authors want, I mean, they want their work to be kind of evaluated and certified in that way. But I think the real reason as individuals is they want their information out there quickly, and they see the benefits of that. And there are scientists I know who say, I have work that is 8 months ahead of where it would have been because somebody posted a preprint. I was able to read it and really kind of get the kinds of benefits that people get from meeting. This is the reason academics go to meetings, is they can hear what people are doing right now and what the work people have just completed. Whereas if you read a journal article, you're reading work that somebody finished a year ago. So really, I think there's this motivation as individuals to control the dissemination, get the work out early. And then there's also the motivation they see the big picture that science itself will move faster. And I think it's like about eight months on average from submission to publication in a journal. And of course, lots of people submit to whatever it is, an average of 1.4 journals before they get into the journal they're published in. So a year is a good kind of like average. And if you think of whatever it is, 1 million papers that we publish every year, if all of those came out, the information was available a year before, that's kind of like 1 million years of information transmission gain brought forward. And as I say, there are scientists I know who can speak to the fact that they're way ahead of where they would have been. And of course, when it comes to COVID-19, I think this was so evident, particularly in the clinical community, because obviously the basic scientists have had 7-8 years since the launch of bioRxiv, but medRxiv had only been going 6 months. It wasn't like we had some massive publicity advertising campaign, and we certainly hadn't we hadn't really contacted anybody outside kind of Western Europe and the United States. And then we see kind of January, February, this wave of submissions from China. We'd hardly ever had any submissions from China on bioRxiv, not en masse. And suddenly it was, this resource was needed, and people wanted to get the information out really quickly. Everything from the kind of basic virology, immunology, host response, through to ultimately clinical trials, and then most recently all the stuff about variants. I mean, it's been this really bizarre situation for me where, I mean, there's no way I see all the papers that go through, but I found myself learning about medRxiv papers from reading the front page of the New York Times, which has been absolutely incredible.
That says something about the pace in which the science is getting through, which kind of goes to another area that I wanted to touch on, which is the editorial process, or maybe review process. Let's say let's reserve editorial for something different. A screening process. bioRxiv and medRxiv are maybe not unique, but more unusual in that you do have a kind of a basic screening process for offensive or non-scientific content or material that might be a biosecurity risk or plagiarism. You do some basic checking. I'm wondering about the boundaries there. And obviously there are no hard and fast rules of what those things are, but how do you think that how do you think the preprint community can deal with some of this? How do you identify papers that are maybe pushing an agenda or unsound methodologically, or some of these challenges that some of the preprints have had? Um, is that something we just pick up after the fact?
Well, yeah, I mean, I think so. I mean, when you talk about something like unsound methodologically, I mean, the simple answer is that we don't. We don't identify things like that. That is the job of the community. And the aspiration is that ultimately, by making the work available, that can be done more effectively than it is now. What we're looking for in screening on bioRxiv, it's mainly things that are out of scope. What we've never wanted to be a place where you go in and all you get is loads of crazy hypotheses written by weirdos. I mean, it's basically sharing the types of papers that people will ultimately put in journals. So there's a kind of a bunch of scope stuff. It's got to kind of look like a scientific paper in the way that most scientists would view a scientific paper. It's got to be nonsense. It can't be kind of creationism or, and those sorts of things are pretty obvious. On the medRxiv front, there's more concerns about danger. So there, it's not, there's no judgment based on whether or not we think the paper's right or wrong, but what is the danger here? So here's how to build a bioweapon. It doesn't really, I mean, the point is, if it actually works, then you don't want to be disseminating that. If you say that there's, if somebody posts a paper saying that cigarettes don't cause cancer, we don't evaluate the quality of the data. We just say that, look, there are some things that should go through peer review first. But the important point to make is that the vast majority of things don't fall into that category. Another example, I'm just kind of poignant now in the midst of the pandemic, is this issue that lots of biomedical journals have talked about for a while, which is what's called dual use research, which is where somebody starts engineering the flu virus to be more infectious. That's a biosecurity risk, but biosafety there are issues around that. So again, that's the kind of paper where we say, you need to go and have this evaluated by experts before it's disseminated, because there are dangers to releasing that. But again, we come back to the fact that the vast majority of papers aren't like that. So that's kind of what the screening does. And I mean, you said bioRxiv and medRxiv are unique. I mean, bear in mind that something like this happens at arXiv as well. They have the arXiv moderators, and they look at papers and they turn the number of things away. And we do it slightly differently because we felt the structure of the biomedical communities were different. But it's essentially the same idea, to remove anything that's nonsense and anything that's dangerous. I had conversations with the folk at arXiv, and I joked that they're worried about nuclear weapons, we're worried about bioweapons. It's that's one of the things. And of course we're all worried that we just don't have absolute nonsense up there. So that's right. Really the process.
Yeah. Another topic that we talked a fair bit about today was retractions, and how this affects trust and validity and the perception of the scientific community broadly. First of all, do you have procedures in place to retract papers that are determined to be problematic in any way? And then related to that, is that connected in any way to the distribution of published literature? So if a paper is retracted by journal X, how do you deal with that in the preprint world?
Yeah, so I mean, so I guess we do. I mean, so the most obvious instance, we have what we call withdrawals, which is basically works much like a retraction. And it's important to emphasize that just like a retraction, you don't take down the paper. You just say, you mark it as withdrawn, but you have a transparent record of what was there so people can see, except in extraordinary circumstances, if there's some legal issue, or again, if there's something really dangerous there. But it's much like a retraction, but the conditions in which you do a withdrawal are slightly different. So the first instance, of course, is if an author posts a paper with us and then says, oh, I was wrong, I don't want my preprints cited as evidence of this because I've done some stuff. So if an author comes forward and says, I would like to withdraw the paper, then they can do that. It's flagged as withdrawn, and kind of, again, much like a retraction, there's a statement which typically says the authors have done more experiments and no longer have faith in their result and don't wish them to be cited. So that's probably most common. If there is an ethics issue determined by the author's institution, then we would do something similar. So if we found out, according to an author's institution, that there was some ethical issues around the work, then we would retract it, on the authority of the parent institution, something like that. What we don't do, and this is the big distinction with journals, is we won't have a paper withdrawn just because somebody says it's wrong. So, and of course, and Ivan Norinsky at Retraction Watch always points out that lots of journals don't do that either. But the point is that bioRxiv and medRxiv themselves have never made any claim to the veracity of the work. So the kind of journal retraction where the journal take another look at it and say, oh God, the authors said that they had found X, we peer reviewed it and we thought they had found X, but now we've changed our mind. That never happens. So the sort of disclaimer on a preprint continues to be there. This might be wrong because bioRxiv never made any claim in the first place, and we're certainly not going to do a kind of whole post-publication review of the work to establish and who would be the arbiter of that anyway. I mean, occasionally there are calls that one should take down papers if they've been up there for a protracted length of time. But I mean, how would you say? Well, I mean, what would that length of time be? Who would make the decision? And what would you say to the authors? And I can think of the guy who solved the Poincaré conjecture and posted it on archive and refused to put it in a journal. Are you really going to say to him 2 years later, you have to take that off archive? It doesn't really make sense. So I think that the key is that that things like other trust signals will accumulate. The most obvious one being this is now published in a journal. And so to your point about what you do with journal retractions, we make matches to a journal article when a preprint is published. So when a preprint is finally published in a journal, it could, now published in Nature, there's this big link. If it's subsequently retracted from Nature, then the link on our site changes from now published in Nature to now retracted from Nature. So that would be, we will essentially aggregate any signals we can about the paper, which includes some of these new third-party peer review initiatives. We have our own commenting site, and then there's there's obviously things like Twitter and blog post mentions. So we essentially aggregate all that information and try to persuade to provide as much information about conversations around the preprint, so that readers can make their own judgment. And the most obvious one being this is now in a peer-reviewed journal.
Yeah, I think that goes to a fundamental understanding of science and the scientific process, that one might put forward a thesis or a paper and some research that supports their thesis. Subsequent research might just prove that to be inaccurate. It wasn't that the paper was wrong. Maybe we just need more data, or people's understanding changes over time with regard to science. To say that you were wrong prior to the creation of the Large Hadron Collider or something along those lines. Well, we didn't have the tools to prove that your theory was right or wrong. Now we do. To presume that we need to go back and correct the entire scientific literature for every paper that was wrong seems an insane, both an insane process notion, but it also fundamentally doesn't understand how knowledge develops.
Yeah, I agree. I mean, I think what I would say though is that what seems to be happening, and certainly has happened in many areas of physics, and we're seeing it in large numbers in biology now, is this uncoupling, this decoupling of the dissemination from traditional peer review. I always say this: affords us an opportunity to rethink how we do peer review and do it better. You know, I mean, right now, the way a journal works is that they essentially make an assessment based on 3 people's notions at one instant in time. Now, I mean, going back to your first question about why do authors post on bioRxiv and preprint servers? I mean, I think one of the things you hear from them is that, well, that's the logical thing to do in the age of the web. And so I think what seems to me is the logical way to do peer review in the age of the web is to put the thing online and then decide how you're going to evaluate it, and not rush to do that, which is what we currently do. We rush to do it because we need to peer review it so we can get it online. It's already online. Let's give us an opportunity to think how we can do peer review, how we can do it better. And the answer may be, as somebody mentioned this earlier about different fields, the answer may be different depending on your field. If it's an epidemiology paper, then we do it in a certain way. If it's a computational biology paper, then maybe we get somebody to run all the code, and the peer review becomes more like a sort of consumer reports type analysis. And then maybe there's some papers that we just don't bother peer reviewing at all because they're so sort of arcane and niche that only 3 people are going to ever read them, and those 3 people are perfectly qualified to peer review them anyway, because scientists do this anyway when they read a paper. So I think that to me is the really interesting question now is what does it open up to the scholarly communications ecosystem in terms of how we do experiments with peer review? And we've heard some examples of that in some of the earlier presentations.
Mm-hmm. Yeah, that's kind of an interesting approach to, and might require some cultural change. I think all of this requires some cultural change. That different domains undertake their science differently, and what double-blind peer review for one domain might work well, whereas an open post-publication peer review system might work perfectly well in another domain. And you shouldn't maybe necessarily judge them differently against the rubric of biochemistry versus social sciences.
Yeah, no, I think that's true. I mean, I think the one common feature that, I mean, certainly when you look at the waves of adoption in physics, which started with high energy physics and then condensed matter physics and the experimental physics, the one common feature does seem to be that, early dissemination makes sense. And one of the early arguments was always that, oh, that works with physics, it's completely different for biology. And what was interesting to me, and one of the things that certainly made me convinced, was we have former physicists and mathematicians at Coldspring Harbor Lab who now run biology labs, and you'd say things, oh, do you think that biology is fundamentally different from physics? And they'd say absolute nonsense. I was a physicist, I'm now a biologist, and let me tell you, it's the same. And it's kind of interesting. You find some of them get a little bit annoyed when people say, oh, it's different, because they say, physics is just as fiercely competitive as biology, and vice versa. So I think there are nuances to how you might do it, but I think it's hard for me to see large swathes of the academic community where early dissemination and this decoupling doesn't work. As I mentioned earlier, I think that there is this unique area where there is some work which, either because the conclusions could change public behavior in a way that would be dangerous, like, for example, so somebody mentioned the Lancet MMR paper. We wouldn't post that on bioRxiv. If we got a paper that said there is a problem with the vaccine, the dangers of disseminating that work early so far, in our view, far outweigh the benefits to it. But again, a small number of papers, similarly dual use research. I mean, another example is HIV denialism. If you disseminating a paper that claims that you can't be infected by HIV through heterosexual sex, we wouldn't post a paper like that, whoever it came from. So I think there are things we need to think about in some areas, but not for 99% of work.
Yeah. Oh, a super fascinating conversation. I'm sorry we need to draw it to a close. Richard, thank you so much for joining us.
You're welcome.
I really appreciate this.